Hi Bobcats, this is Miss Lee, and today's video lesson is on properties of operations. So we've already discussed one of the properties, and that was the distributive property. Because the distributive property is so important, we needed to do a separate lesson on it. So if you need to go back and rewatch that video, please do so. It's called Distributive Property 2.0. In the meantime, we're going to go ahead and talk about some more properties of operations that you need to know. Okay, make sure you're taking good notes as you watch the video. And I want you to look at these two expressions and determine factor fib. 6 plus m and m plus 6. Do you think those two expressions are equivalent? And then what about 3 times t and t times 3? Do you think those two expressions are equivalent? Well, look at what's being done. Okay, what did they do here? How did they change from 6 plus m to m plus 6? They just switched the order, right? Okay, what happens if we replace the variable with a number? Let's replace the m with a 2. And 6, add them together. 6 plus 2 is 8. Do the same thing with the second expression. Substitute the same value for m and add 2 plus 6 is also 8. So they are equivalent. 3 times t and t times 3. How did these two expressions change? Did the numbers or the variables change? No, it's still a 3, it's still a t. Did the operation change? No, it's still multiplication. They just flipped the order. So let's do the same thing. Let's substitute a 4 for t. 3 times 4 is 12, and do the same thing over here. Substitute a 4 for t. 4 times 3 is also 12. So they are equivalent. This property is what we call the commutative property. And the commutative property says the order in which two numbers are added or are multiplied does not change their solution. So you can take two numbers that you're adding or two numbers that you're multiplying, you can change their order and you're still going to get the same answer. So look right here. The first expression has 4 plus a. And they change the order in the second expression to a plus 4. You can do that. That's okay. Here, first expression has m times 8, and then they change the order to 8 times m. You can do that. That's okay. You can change the order of two numbers you're adding or two numbers that you're multiplying, and you're still going to get the same answer. What you cannot do is change the order of two numbers that you're subtracting or two numbers that you are dividing. If I have 5 minus 10, and I change that to 10 minus 5, are these the same? Well, 5 minus 10 is going to equal a negative 5, where 10 minus 5 equals a positive 5. So you do not get the same answer. So it doesn't work for subtraction. What about division? If I have 20 divided by 2, well, that equals 10. But if I do 2 divided by 20, that equals 2 divided by 20 equals 1/10. Is that the same as 10? No. Okay, so the commutative property only works for addition or multiplication. It does not work for subtraction. It does not work for division. Okay, what about these expressions? Determine factor fib. Are they equivalent or not equivalent? Always look at it and try to figure out how the expressions changed. So I look at it, and I know that it's a 9 plus 3 plus y, and here I have a 9 plus 3 plus y. What changed was the parentheses, the grouping. In my first expression, the grouping was around the 3 plus y, and then it changed and put it around the 9 plus 3. So when you change your grouping, you're changing the order that you're doing the operation, right? Because PEMDAS says to do parentheses first. But everything was all addition. The numbers didn't change, the letter, the variable didn't change. So would you get the same answer? Sure you would. If you're not sure, substitute a value for the variable. I'm going to substitute a 2 for the y. Parentheses first, 3 plus 2 is 5. Add that to 9, we get 14. Let's do the same thing over here. Substitute a 2 for y. PEMDAS says do parentheses first. 9 plus 3 is 12, plus 2 is 14. Same answer. They're equivalent. Look at the next one. What changed? Again, just the parentheses. The order and the operation stayed the same. 2 times 3 times y. 2 times 3 times y. What changed was the grouping symbol, the parentheses, and you can do that with multiplication. You can do it with addition, and you can do it with multiplication. You cannot do it with division or subtraction. This property is what we call the associative property. Changing the grouping of numbers being added or multiplied does not change their solution. Okay? Then we have the inverse property. And believe it or not, you've learned this property this year in 6th grade. We just didn't call it the inverse property. But the inverse property says that the sum of a number and its opposite is 0. We learned that when we talked about integers. Remember the zero pairs? A positive and a negative, 0 out. Okay, so the sum of a number and its opposite is 0. The product of a number and its reciprocal is 1. We did this with our fraction division. So I have 1/2 times 2. Product means to multiply. Remember, to multiply with fractions, everything has to be in fraction form. So we turn the whole number into a fraction by putting it over 1. Multiply the numerators. 1 times 2 is 2. Multiply the denominators. 2 times 1 is 2. And that simplifies to 1 whole. That's the inverse property. Here, the reciprocal. Okay, 5 plus a negative 5 equals 0. A positive and a negative, they zero out, right? Positive 5, negative 5, it zeroes out. Okay, these are the inverse properties. And then the last one is the identity property. Think about identity looking in the mirror. When you look in the mirror, what do you see? You see yourself, right? Just reflected. But do your color of your eyes change? No. Okay, so the sum of a number and 0 is the number itself. So this property you've learned in elementary school. You just didn't know that it was called the identity property. But you learned that any number plus 0 equals the number itself. You also learned that any number and 1 is the number itself. So if you have a number and you want to rewrite it, make it equivalent expression, but get the same answer, all you have to do is either add it to 0 or multiply it by 1. Okay, so we have a model here. We need to figure out which expressions can be used to represent the tiles shown and select all that apply. So the first thing I'm going to do is look to see the total tiles I have. If I look, I have 8 A tiles and I have 4 B tiles, and they're all positives. So looking at my first choice, 2A plus B, no, I have way more than that, so that's not equivalent. What about 8A plus 4B? That's what we have here, isn't it? So that's an equivalent expression. Do we have 8 groups of A plus 2B? Well, I can use my distributive property, right, and distribute the 8. 8 times 1A gives us 8 A's. So far, so good. But now we distribute the 8 to the 2B. Distribute means by multiplication, and you should get 16 B's where we only have 4. So that's not equivalent. 4 groups of A plus B, I can easily make 4 groups. Here's group 1, here's group 2, group 3, group 4. What do we have in each group? We have 2 A's and 1 B, not 1 A. So that one's not equivalent. Here we go again, 4 groups. Do we have 2 A's in each group? Yes. Do we have 1 B in each group? Yes. So that's equivalent. Okay, what about 2 groups of 4A plus B? Well, can I split this evenly into 2 groups? Sure. Here's 1 group, and here's 2 groups. So how much do we have in each group? I have 4 A's, which is true, 4 A's, but I have 2 B's. This only shows 1 B, so that's not equivalent. So there were only 2 equivalent expressions. All right, good job, Bobcats.